Hello and welcome back. In this video, we're going to take a look at another collection data type similar to the tuples that we spoke about in the previous video, but in some ways also different from the way tuples operate. And so arrays are defined as phased size collection of data of the same type stored on the stacked memory. So already you are spotting a difference between the tuple and the array here. In the tuple, you could mix items of different data types into a tuple, but in an array, the requirement is that all the items in the array should have the same type. So you can't have an array where some of the items are integers and some are float, or where some are int 32 and others are in 64. You cannot mix up the data types that way. That is the first difference between the array and the tuple. And the format for declaring an array is you use the square bracket, you specify the type, followed by a semicolon, and this n here stands for the number of elements that are going to be in the array, because the number of elements also is part of the array's data type. So if I have an array of i32 with 4 items, it is not the same as an array of i32 with 5 items, because n is different for the different arrays. And the way we access individual items from the arrays is to use the square bracket, and you specify an index similar to how we were accessing items from a tuple, but instead of using the dot notation in an array, you use the square bracket and you specify the index, and the indices always start from 0. So let's look at how to create an array, and let's imagine we are building a program to store the class score of a student's exam marks. Okay, so we say let scores, and then we are doing a type annotation here. It is optional because, like I have already showed you, Rust is able to infer the types of the variables based on the values that you assign to them. So as long as you're going to assign, you are going to initialize the variable, it will be able to infer. But for clarity and the sake of learning, I'm going to I'm going to include a type annotation. So let's say we want a collection, which in this case is an array, that stores only F32s. And for this particular array, we want to store just 3 F32s in there. So this is how we declare that, and then we can come here and use the same square bracket notation to initialize the items in the array. Okay, so in this case, we are storing just the score of 3 examinations that a student took. So let's say for the first examination, the student got 53.12. For the next one, he got 78.09. And for the last one, the student got 65.19. Okay, and don't forget your semicolon. So let's start off by learning how to print the entire array. And like you learned from the tuples video, the array also doesn't implement the display trait, and so we have to use the same approach that we use to print the tuple to also print out the entire array. So I'm going to do print ln, and I'm going to print the entire arrays here. First of all, I'm going to do it without what we are supposed to do, and then we'll see the error that we get. Okay, so automatically you can see that the linter is complaining, and it is saying that the array doesn't implement the std-fmt display trait. This is similar to what we saw in the tuples video, and so the way we fix that is to do a colon and a question mark, and then now we will be able to display our array. So let's save and run our program. Okay, so you can see that indeed the array has 3 items in it, and we have successfully printed it out. So this is one way of declaring an array and initializing it. And like I said, the type annotation can be optional, and so I can take away the type annotation, and in this case Rust is going to infer that this is an array of 3 F64s. Remember that I said when it comes to floats, the Rust programming language is always going to default to F64. So because we are not explicitly annotating it with a type, it is going to assume that is an array of F64 containing 3 items. So I'm going to bring back our annotation because this explicitness is also good so that we are sure we are getting F32s instead of F64. So this is one way. Let's see another way of declaring arrays. Let's say we want to store the score of a student who got all zeros in all the 3 courses. So what I can do here is I'll say zeros is equal to, the way you do that is you bring the value that you want, and then I can specify the number of items. So basically what I'm trying to do here is, in fact, let's print it out and I will explain what this code does. So I'm printing out zeros. I'm printing out zeros and zeros over here. So let's run this program. And you can see that with this style of initialization, what happened is that each item in the array was set to 0. And the way you achieve that is you bring the default value that you want to set for all the items in the array and the number of items that you want to set. So if I change this to 1, it is going to set every entry in zeros into 1. And as usual, you can always type annotate it so that you are sure of which type you're using. For in this case, I can say an I32 and then 3 items in there. So this is another way of creating arrays. Okay. Then the next thing I want us to look at is how to access individual items from the array. And like I said, arrays are quite similar to tuple in terms of how we access them, but the notation is different. So in tuples, you use the dot notation, but in arrays, you're going to use the square bracket notation, and the index of interest, which is x here, is going to be specified as an integer that targets a particular item from the array. So let's say I want to I want to access 78.09. Because indexing starts from 0, 78.09 is at index 1, and this is at index 2, and the first one is at index 0. So let's print the first item. So I can do print ln, and I'll say first item, and for the first item I am going to access scores 0. So this is what indicates that we want to access the item at index 0. So you use the square bracket notation and you specify the index as an integer. Let's get the last item as well. So I'm going to get the last item. Let's remove the s's from here and here. And the last item is going to be at index 2 because this is index 0, index 1, and index 2. So let's compile and run our program once again. So you can see that the first item is 53.12 and the last item is 65.19, and it was all possible because of the square bracket notation that allows us to specify the index and get what we want. Okay, so how about mutating or changing items in the array? What if for some reason we think the student, instead of scoring 53.12 for the first course, actually scored 45.05? What we can do here is to access the index of interest, which is index 0, and set it to a new value. So let's say 45.01. But why is the linter complaining? And by now you should know that the moment the linter complains, the compiler is also going to complain, especially if it is this red squiggly line underneath it. It is an error, it's not a warning, and so the compiler will fail. So let's hover over it and you'll see it says cannot assign scores, blah blah blah, is not declared as mutable. So by now you should always remember that Rust variables are immutable by default, and so to make it mutable we have to always remember to bring our mute keyword. And now if I come and print the entire scores again, you can see that the item in the first index will be changed to reflect what we did. So now you can see that for the first index, it is 45.01 instead of 53.12 as we started with. Okay. Now, similar to tuples, we can also destructure the items of an array into individual variables using the same destructuring technique that we learned about in the tuples video. So let's assume that the first score represents the student's score in calculus, the next one represents the student's score in algebra, and the next one represents the student's score in electronics. So what we can do with the destructuring is I'll say let, and mind you, I am using square brackets here instead of the normal brackets that we use for the tuple, and that is because this is what is required to declare arrays. Okay, so I can come in here and put in the names of my variables. So calculus, and this is algebra, and this is electronics, and I'm going to set it to scores. So by doing this, what we are doing is what we are effectively achieving is that the first item or the first score here is going to be assigned to calculus, the second is going to be assigned to algebra, the third is going to be assigned to electronics, and so we can go ahead and print them out to see. So let's print out what the guy got in calculus over here. Let's print out what he got in algebra here, and let's do electronics also here. And so now I can put calculus, algebra, and I can put electronics over here. So let's compile and run. And you can see that indeed the destructuring works. So we know that calculus, the person got 45.01, for algebra 78, and electronics 65. So this is how we do destructuring, and everything you learned about being able to mutate these variables on the left in the tuples video also applies in this scenario. So if I want to be able to change this calculus, then of course I have to make it mutable. Otherwise, I cannot change it. That is a core Rust requirement that works across the entire language. Okay. All right. So the last thing I want us to learn about is something called index out of bounds error. So you can see that the array is bounded, and in the introductory section, I told you that the type of the array is actually determined by the type of its element and the number of elements in the array itself. And that is why I said if I have an array of I32s that has 4 items, and I have another array of I32s that have 5, 6, or 3, anything apart from 4, then those two arrays are entirely different. Okay, so an array is bounded by the number of items in itself. And so there are times when by mistake you will access an index that is out of the range of that array, and an error is going to be thrown. Okay, so let's verify that. So what I'm going to do here is I know the array has 3 items, and so my index or the range of my index is 0 and 2 inclusive, because 0, 1, and 2. So 0, 1, and 2. That is what makes up the 3 items for me. And so if I try to access anything at index 4, then it is going to be an index out of bounds. Or if I try to access anything in the negative with a negative index, then it's also going to be out of bounds because there is no negative indices in here. So what I'm going to do here is I'm going to try to print the item at index 4. So this, and I'll say non-existent, because I know it doesn't exist, but we are just trying to see if the compiler will catch us anyway. So I'll say scores, and I'll try to access index 4. And even before we compile, the linter is giving us an error, and it is saying index out of bounds. Why? Because the length is 3, but the index that we are trying to access is 4. So this is something that, depending on how you set your compiler, for example, you can see that there is this annotation here that we can add to our program to turn off unconditional panic. And what will happen if we let the compiler ignore this is that it will compile all right, but at runtime it is going to panic and the program will stop. And this is part of the safety features of Rust, because in other programming languages, especially other low-level or systems programming languages, some of them allow using indexes that are out of range, and what usually happens there is surprising and introduces subtle bugs or errors into your program that is very difficult to uncover and to fix. So the best decision that Rust takes is that once you're trying to access anything out of bounds, it will panic and crash your program so that the program stops without continuing and doing something that is not what it is expected to do. So this is it for arrays. Thank you very much for watching, and I want to encourage you that you are doing well having stayed with me up until this point. I want to encourage you. I want you to know that you can learn anything with determination. So keep practicing and things are going to work out. Thank you very much, and I will see you in the next video.